Welcome back, everyone. Our next speaker is David Rawson. He's a senior Android developer at Lightspeed Commerce. As an experienced speaker and contributor to open source projects like Detect and Kotlin Poet, David has been in the trenches for nearly a decade. He's challenging the status quo and diving into the most common advice given to new Kotlin and Android developers, and revealing how it can actually impact our code bases and careers for better or worse. Give it up for David.
Thank you. So the title of this talk is Dangerous Minds, How We're Getting Developer Education Wrong. And that, of course, refers to the 1995 movie starring Michelle Pfeiffer called Dangerous Minds. But have you actually wondered what was the dangerous mind inside Dangerous Minds? The movie actually never mentions those words verbatim, and there's no official source for what dangerous mind actually means. It apparently had another title. So of course I asked ChatGPT, and it came up with an answer, but we're not here to reminisce about 90s movies, no matter how much their soundtrack slaps. We're here to talk about software engineering. So in the context of software engineering, what could a dangerous mind be? And you might think, well, the dangerous mind that's very apparent right now is language models, and language models are going to replace everyone, and that's the danger here. And at least at the present stage, the language models are more like an assistant rather than a replacement. So you can easily get language models to hallucinate about a topic. Like here, I've got it to spit out some API calls that don't exist, that are just kind of like a joke. So what then could we be talking about with our term dangerous mind? So for the purposes of this talk, a dangerous mind is a mind that doesn't really have a sense of the depth of software engineering. And despite not having this depth, there's also an overconfidence. And not only that, it's a mind that wastes time in disputes about things that at the end of the day don't really matter. And some of you might see where I'm going with this. So in something called the Dreyfus model of skill acquisition, you start out as a complete beginner with no knowledge, and then you start learning like a few little rules. So if we consider, for example, English spelling, you might learn the rule I before E except after C. So you might start by repeating that rule to yourself, like, to help you remember it. But at some stage, you actually remember the rules by heart. But you need to go beyond that and develop an intuition and a big picture. So this is what I've seen in my experience of working with really, really good software engineers. They see the big picture, and they've got this expansive view over the entire field. So that's where we want people to be, obviously. But like is explained in this blog post called The Rise of the Expert Beginner, people start out learning the rules, but then they get stuck at a stage called expert beginner. And this is when they know the rules, but they're not going on to develop the intuition and the big picture. So they're stuck in a local maximum, and if you're stuck there, it sucks for you, and it sucks for your teammates as well. And the kind of logic for being stuck in expert beginner is a circular one. So it tends to go, well, I know the rules, therefore I'm an expert. Because I'm an expert, even if there's other things to learn, they don't matter because they're irrelevant. So the thesis of this talk is that the way that we're giving out advice to beginner software engineers is actually in danger of inculcating this dangerous mind, this mind of the expert beginner. So what we're going to do is we're going to look at two pieces of advice that might be given to a beginner software engineer. And we're going to see how those pieces of advice fall down, how they're incomplete or they're shallow. how they miss the big picture. So the first piece of advice we're going to explore is some advice about naming. The advice reads, classes and objects should have a noun or noun phrase like customer, wiki page, account, and address parser. Avoid words like manager, processor, data, or info in the name of a class. So the first thing with that advice is it's actually extremely difficult to follow. So if we look at the Now in Android project, which is a project put together by Google to show you how to build a scalable Android app, you can see they've got this class called user data, and it's basically just a bundle of information related to a user. And so user data isn't such a bad name there. You can go on and find examples using info. Remember the advice said to avoid info in a class name. And in the DuckDuckGo Android project, which is open source, and if you're interested, it allows you to see how the sausage is made for a very large Android project. They have this class called AmpLink info. So often you end up in this scenario where you have something important and you want to bundle it or associate it with something else. And if you don't call those kind of classes info, what would you call them? You might think, okay, maybe we should use like a triple or a pair, but those have their own problems as well. And then remember the advice says to avoid using processor in a name, but what if your class actually is a processor, like this JSON class symbol processor from Moshi? And then you might say, okay, well, the advice only says to avoid processor. It's not saying you can never use processor in a class name. But in my experience, people take this advice really, very seriously. They're starting out and they're looking for something to grasp to, and this kind of thing tends to be it. And then there's the advice to avoid manager in a name. And actually, you can find examples of high quality public APIs where they have used manager in a class name. So this example here is from the Android AOSP, the Android source code, where they have an activity manager class. And even if you consider a classic Android project where you have a repository, which is an abstraction over a data source, you could call it repository, or you could call it manager. It wouldn't really make much difference as long as you followed the same convention throughout the project. And that leads us to a bigger picture here, which is that advice about class names is at best local. It's not global. And even if that advice was local for a project, you wouldn't handle it by just going around dispensing advice. Don't name the class a manager. You'd handle it using a code scanner. So for example, if you were using detect, which is this Kotlin code scanner in your project, then forbidding manager as a class name would just be 3 lines of YAML. And if you were using lint in your project, then it'd be fairly easy to write a lint rule to achieve the same. And the types of lint rules that deal with names tend to be the easiest types of rules to write. And going even further, there's all kinds of problems with names in general. So, okay, what if you have a class called offset and you want to write a Kotlin file that contains extension functions just on offset? Would you call that offsets.kt, or would you try and copy, I guess, what Swift does and do offset plus extensions.kt? Or would you be kind of humble and put offset in lowercase, or would you, where would you put them? So you might think, okay, well, if we say offset plus extensions or offset utils, then it's kind of coarse, and we want something really elegant. So what we're going to do is we're going to copy the example in java.util.concurrent. So in that package, they have a class called an executor. And then the factory functions for creating executor are in a class called executors. And then that's kind of neat, isn't it? Because we can do executors.new single thread executor.as coroutine dispatcher. So that might work if you have like a user class. The extension function would be in users.kt. It's less elegant in something like gold. Gold is an uncountable noun in English, so you say golds, it sounds a little bit like, you know, buying a potion in Dungeons and Dragons with 100 gold, right? 100 golds. And if you have a faux pas in your project, what are you gonna put the extension functions for that class? And you can find better examples than that, like abbreviations that end in S are hard to pluralize. So these kind of problems with names happen a lot. So in Kotlin Poet is an API or a library for helping you with code generation. And they have something called a spec, which is like a blueprint for creating a class using a code generator. So like a fun spec is a blueprint for creating a function. So you might have an interface which represents a blueprint that can have annotations. You call that annotatable. And likewise, if you had a blueprint that contains that could have kdoc, you could call that documentable. What then would you call something that could have a type spec? So a type spec is a blueprint for creating a class or an object, and files can contain blueprints for classes and objects, but classes can also contain blueprints for classes and objects, because you have nested classes and inner classes and so on. So even Galaxy Brain ChatGPT can't come up with a name that sounds, you know, really elegant and beautiful. There are all kinds of criticisms that you can level at names. So there's this blog post from 2006 called Execution in a Kingdom of Nouns. And it's criticizing Java, essentially. So it's saying that in natural language and in English, you would say, get the garbage bag or rubbish bag, I suppose, from under the sink, carry it out to the garage and dump it in the garbage can or rubbish bin, if we're using New Zealand English. And even though that's the case in Java, you'd have to write something like this. You'd have to do retrieval strategy factory.create, strategy.withhands.retrieve, garbage bag, and so on and so on. So you'd end up with a style of problem decomposition where every single little action is relegated to some little noun that's responsible for that action. So you might think, okay, wait a minute. So in Jetpack Compose, we have this thing called a focus requester. And we use the focus requester to request focus. Isn't that like asking? Isn't that like Kingdom of Nouns, where we're asking the carrier to carry out the garbage and so on? So I think this is getting to the real problem with all this advice about naming. It's almost promising too much. It's promising a world where if you remember the right magic spell, the right combination of names in your project, that you're going to end up with something that's really easy to understand, that just reads like Twilight, basically. Like, you know, in Twilight we have you know, Robert Pattinson's character does this, and Kristen Stewart's character does this, and that's not going to be the case. Like, so if it's not the only thing that matters. So you could obviously have an API where you have view.requestFocus, which is what the old API was, and that would certainly scan better. It would make a better a Twilight novel, but it's not the only concern here. We're less like Twilight, and we're more like mathematics. So I'll explain what I mean. So I saw a pull request recently where the developer had learned the rule avoid get in function names because get is ambiguous. And what they'd done is they twisted themselves into knots trying to find the exact word that would match what they're doing. And the effect was to make everything very, very difficult to understand. So you'd end up with a class that had some functions that begin with calculate and some begin with retrieve. You know, Get ain't that bad. Like if you look at the KSP API, so the Kotlin symbol processing API, all the functions on Resolver begin with get. It doesn't try and make this distinction between retrieving a cached value and newly creating it. So the effect of that is to make API discovery very, very easy. You don't need to remember, okay, do I have to type in retrieve or calculate to find what I want? You just type in get and you see everything that's available to you. So what am I saying here? Am I saying that names don't matter, that names aren't important? I'm saying that names are intensely important, that they matter, and we should spend effort trying to find the right name for our project. But at the end of the day, these names, we have little bits of code that do things like render something on a screen, and the names we assign to these pieces of code, they can't capture completely the essence of what this code is. And it's much more like mathematics, where you have some concept like the ratio of the diameter of a circle to its circumference, and you assign something that represents it, like the Greek letter pi. And you just have to get good as if you're becoming a good software developer, you have to be good at finding out what something means and then just abstracting it away with some kind of symbol for it. So what I'm trying to say here is that names aren't solutions, like the great American economist Thomas Sowell says. So often in software engineering, we have to choose an alternative between a number of alternatives where each alternative has its downside, and we just pick the one with the least downsides. So if we don't remember that when we give out our advice and when we're then it can become a little bit like Mr. Bucket. So bear with me for the analogy here. Mr. Bucket is a children's game where there's a motorized bucket, and a motorized bucket wanders around on the ground spitting out ping pong balls, and people run around, the kids, the players run around picking up the ping pong balls. So here, the people who well, the expert beginners, I suppose, they give out the ping pong balls of shallow advice, and the people are just trying to level up, just trying to get better at their career, so they can make more money and look after their family. They're going around picking up the ping pong balls and internalizing them and just gathering a bunch of shallow rules about a profound subject. So it's that kind of thing often gets disguised in the form of best practices, like explained by Ilyan Germanov, one of the software developers at Reddit. So taking that initial advice, how would we rewrite it? How would we refactor it in a name in a way that is less likely to lead to this dangerous mind? So I tried to imagine giving advice to a younger version of me that would avoid me getting stuck in expert beginner. And here's how I do it, but I'd be interested in hearing how you would phrase it. So the first thing I've put is getting a good instinct for names is hard. So the idea here is to communicate the final goal, the big picture, which is that you have to arrive at getting a good instinct for names. And then I put, you have to learn to walk the tightrope between obscurity and verbosity. So that's saying that, well, there's a trade-off to be had here. Follow the idiomatic names in your community, in your language and open source community. So this is an important point. So open source community and community in general can be like garlic for the vampire of the expert beginner. So remember, the expert beginner gets stuck because they don't get enough contact with the higher levels, with the intuition and the big picture. So this kind of community can push that person to get out of their local maximum. And then we've put, for team projects, enforce naming conventions using static analysis to avoid bike shedding. So obviously the modern solution to this naming problem is to create conventions and create templates and use things like Arch Unit and Lint and Detect and so on to enforce it. So at the end of the day, decisions on names are compromises too. So learn to deal with names that aren't perfect. So that was the first piece of advice that we saw that was a little bit shallow and missing the big picture. Let's look at some more advice. And this time we're going to look at some advice about testing. So the advice reads, dear anti-TDDers, you cannot win this battle. So TDD stands for test-driven development. Now this is distinct from, there's two things here. There's writing tests, which is something everyone agrees on. And then there's the discipline of TDD. So TDD, or test-driven development, we're gonna insist that you write a failing test before you write any kind of production code. So it's explaining a discipline for when you write the test. Now, the advice goes on to read, this is called double entry bookkeeping. You don't need to employ the discipline if you don't want to, but would you hire an accountant who didn't? So just to explain the analogy, in double entry bookkeeping, each transaction has an entry in a equal and opposite ledger. So for example, if you take out a loan of $10,000 and you get $10,000 cash, that will be recorded in the debit ledger. But at the same time, the fact that you owe $10,000 will be recorded in the credit ledger. And the problem with this advice that I see is that the worst kinds of tests have this double entry property. So let's consider this payment processor class. So if we write a very naive test there, then you can see that every implementation detail in the production code has an equal and opposite entry in the test code. And the problem with that is it's tautological. It's like a serpent consuming its own tail. So the production code is correct because the test verifies it as correct. The test is correct because, well, it copies essentially what the production code does. And I can even remember thinking about testing like this. So I would write some really sloppy production code, like this view model here where I've spelt birthday incorrectly. And then without even checking it through, without even looking at it twice, I would just go on to write a test. The test would catch the spelling mistake, but it was only because I wrote it out twice, and it caused me to have more scrutiny of my code. It wasn't a useful long-term contribution to the project. So this is all talking about test doubles. So test doubles, obviously in a test you can't use real production instances of your classes. You have to have a substitute. And within test doubles, you have mocks, which are created by a framework, and you can record a behavior on them, which is called stubbing, and then you can verify different behaviors on them, see if they actually interacted in the way that you want. And then there's fakes, which are like lightweight implementations of production code. So like a credit card processor that just records the transaction in some ephemeral state without actually withdrawing money from people's bank accounts. And if we were to refactor that test and use a fake instead, so use this different kind of test double, it would certainly improve things. Now you might say that's also isn't that also tautological? So when you write the fake, aren't you also just copying the production code? And one answer is that that style of testing using fakes is a little bit different. So if you consider standard Android architecture where you have a view model, and the view model talks to a repository, and the repository talks to a data source, like the database or an HTTP server. Usually with fakes, you're just substituting the fake at the bottom of the stack. So you'll substitute this SQLite database with an in-memory database. And this is all explained in great detail in this book called Software Engineering at Google, Lessons Learned from Programming Over Time. And instead of all this kind of expert beginner level discourse about test doubles and testing, you have this really profound explanation of test doubles in terms of two criteria. One of them is applicability, so how suitable is the test double for your particular code base and your particular solution. And the other criteria is fidelity. How true is your test double to the production code? And then within applicability, you can ask about whether that test double is making your code brittle or not. So by brittle here, it means that when the implementation details of your production code change, are your tests having to change? Which can be the case if you overuse mocks. And the other one is your test double, is your choice of test double making your test code more complex? So in order to understand the tests, are people having to wade through reams and reams of stubbing or recording behavior on mocks? So there's a conversation to be had about the right choice of test double, like in this blog post from Jamison Williams, who was at Reddit before. But unfortunately, a lot of Android projects I've seen, that they never even get to that level. They just kind of assume that everything needs to be done in the way that initially comes to mind. And why is that the case? Well, it's hard not to blame the level of the discourse about testing. So we saw that all this emphasis about when you write the test, like do you write the test before you write production code, or do you write it after? And another example is you might remember when Elon Musk took over Twitter, and whatever you think about the politics of Twitter before Elon Musk was there, there were clearly a lot of talented engineers. And around that time, one of these influencer types came out with a video called "Is Twitter's Treatment of its Software Developers Fair?" And one of the points it was discussing was it was looking at just the number of unit tests that they wrote, and it was kind of like that meme, the number of unit tests is too darn low. So we have all this emphasis on when you write the test and how many unit tests you write. So what if all of that was just a red herring? So we have this problem we need to solve by decomposing into classes and functions, and we have to do that in a way that enables testing both for our own code and then people who use our code. So that suggests the problem is more about design. So and like John Ousterhout here from A Philosophy of Software Design, which is a really great book I recommend. You can speculate that just concentrating on solving the production code in front of you is going to inhibit that finding the right design there. So why would this problem be about design? Well, you can think about libraries or SDKs that you really like using, that you find really good. I think more often than not, there's going to be some clever way that code is testing itself, some clever solution. So for example, some of you might know the library from Airbnb called Showcase, and what it will do is it'll take your composed previews and make them into an app that you can use for demoing a design system. And they have this very nice test set up, and it's basically a parameterized test and a driver for that. The driver will run the real processor over a set of inputs, which are files in a resource directory, and it'll compare them. It'll compare the actual output against the expected output, which is also stored in files. So really clever way of testing this kind of thing. And not only that, really smart libraries, really smart code is going to do things to enable you to work with that code in your tests to make it easy for you to test. So we've seen how Room does that with the SQLite, with being able to substitute an in-memory database for a SQLite database. But there's other examples, like I think Lint is a great example. Lint has this really nice testing API that you can use to test your own lint rules. So given that design is the issue here, how do we arrive at the right design? So that involves taking our low-level advice, write the test first, or write a large number of unit tests, and just taking it to a level that's more abstract. And I think a philosophy of software design does really good and does really well in this area. It explains more abstract principles. And one of them, for example, is design it twice. So the idea here is that we should be humble with our designs, and we shouldn't assume that the first thing we come up with, the first decomposition into classes and functions is the best way of doing things. We should take our initial draft and then design it again using our learnings from our first draft. So we've seen two sets of advice, one about naming and one about testing. And we've seen how both of those pieces of advice are actually shallow and they fall down. So what's the takeaway for us? So our advice needs to rise to the occasion. If we're giving advice out about accessibility, for example, where everything is clear cut or black and white, then it makes sense to dispense a whole lot of best practice and rules and so on. But if it's something profound like naming or testing, our advice needs to go beyond just repetition of mere rules, lest we create this dangerous mind that we don't want, the dangerous mind of the expert beginner. So I'm going to leave you with the words of Coolio. So they say I got to learn, but nobody going to teach me. If they don't understand, how can they reach me? Thank you.
Thank you very much, David. We've got time for questions. Does anyone have a question for David?
That was a really cool talk. Thanks. You said you're working on open source projects. Have you seen any of these dangerous mind concepts being applied on people doing PRs into open source projects, and how's that sort of worked out in that ecosystem?
Yeah. My feeling is that open source tends to be better than commercial projects in that respect. That being said, it's not impossible to find bad examples within open source. Does that answer your question?
Yeah.
Yeah.
Anyone else?
I guess I just wanted to say that just because something is open source, it doesn't mean it's perfect. And likewise, it doesn't. If someone contributes to open source, it doesn't mean that they're necessarily a better developer than someone who doesn't contribute. Like I think that there's a danger of like worshipping people who are in open source. But that being said, the best commercial project that I worked in, the engineering management there was really encouraging of people to do open source, and the idea was that the open source contributions would kind of calibrate the engineering level. So you'd make sure that if someone was a senior, then they actually matched peers in the industry at that level, and the means of evaluating that is outside the company. It's not a hermetically sealed bottle where people can just have a fancy title without really earning it. Yeah.
Hey, no more questions? Thank you very much, David. Here's a little present for
Thank
you.
you.